Hi, my name is Emil Michael. I am the chairman and CEO of DPCM Capital. I'm a four-time entrepreneur, and my latest endeavor was being the chief business officer at Uber, effectively the number two, where I focused on raising money, added up to about $15 billion over my 4 years there. I ran our China business and our enterprise business, along with our Russia business. Last year, we launched our first SPAC. We raised $300 million. And the idea that I had was to make sure that we were surrounding ourselves with former operators and entrepreneurs in the SPAC, both on the board level and as advisors, so that we could pick a company that we could truly partner with over the long term and add value to over the long term. Today, we're happy to talk about the deal we announced with D-Wave, which is the leader in quantum computing in our view. I'm especially excited about the leadership under Alan Barrett. He's both technically deep in a way that is unique in the industry and commercially minded. And D-Wave, therefore, I think has the best chance at being the largest quantum computing independent player in the market. They have real customers today with real applications, delivering real revenue to the business. Now, I want to give a transaction overview. As you can see in this slide, we raised $300 million, which is in trust. D-Wave has a pre-money valuation of about $1.2 billion. Upon closing, we expect to have a market cap of approximately $1.6 billion and an enterprise value of $1.3 billion, assuming no redemptions by public stockholders. And we're excited to move forward with this transaction as soon as possible. While we believe our targeted valuation compares favorably with the peers, to further incentivize investors to invest and to not redeem, we've incorporated a very innovative bonus structure to non-redeeming SPAC shareholders, which will be quite compelling as it effectively reduces the cost basis to all shareholders in the SPAC who decide not to redeem. And now I want to hand it off to Alan to talk about the company in detail. Thank you.
Thanks, Emil. As Emil said, my name is Alan Barrett, and I'm the CEO of D-Wave Systems. D-Wave is the quantum computing hardware, software, and services company. Quantum computing uses quantum mechanical effects, including superposition, entanglement, and tunneling, to compute problem solutions significantly faster than they can be computed using classical computers. At D-Wave, we know that quantum computing is going to drive very significant and very positive change throughout the world, and that this will happen through not only revolutionary applications, but also evolutionary applications. Even applications like employee scheduling or manufacturing plant floor optimization or shipping logistics optimization, they can all benefit significantly from quantum computing. On the revolutionary side, applications like developing designer drugs, or new materials discovery, or global weather modeling, or carbon dioxide reclamation and reuse. These are all problems that simply cannot be solved today using classical computers, but they will all be made possible with quantum computing. However, the thing that makes D-Wave different from every other quantum computing company is that everybody else talks about what can happen or what will happen, but we talk about what is happening. And the reason is that we are the only quantum computing company with commercial quantum computers supporting Global 2000 customers and real business applications. There are just a few points that I'd like to make on this chart. Our primary business model is a cloud-based recurring revenue platform as a service model. What I mean by that is that our customers have applications that require quantum compute cycles, and they pay us on a recurring revenue basis to access those quantum compute cycles through our quantum cloud service. However, currently, many customers need help understanding which applications can most benefit from our quantum systems and how to build out those applications. As a result, we also have a professional services organization, as well as a professional services component to our business model. Currently, about 50% of our revenue is professional services, and 50% is recurring platform as a service revenue. However, as we look out over a 5-year time frame, we will rapidly grow to the point where well north of 90% of our revenue is recurring platform as a service revenue. The reason for this is that our professional services engagements are relatively short upfront engagements, but once those applications move into production, they run year after year after year, generating ongoing recurring revenue for D-Wave, building backlog, and establishing a more predictable revenue growth stream. We were the first quantum computing company to deliver a real-time quantum cloud service to market, and that's our Leap Cloud service, and it's currently backed by our 5,000 qubit Advantage quantum computer. We have a very extensive IP portfolio with over 200 US granted patents and over 100 in process worldwide, and this covers everything from superconducting circuit fabrication, because we do use superconducting technology, to quantum circuit design, to I/O, to refrigeration, and up through to hybrid solvers and applications. In fact, last year in 2021, we are in the top 5 for quantum patents alongside IBM, Google, Intel, and Northrop Grumman. So we're in very good company and way ahead of the other independent quantum computing companies. There are 5 important differentiators that make D-Wave unique in the quantum computing industry. First, we decided early on to take a practical approach to quantum computing. What I mean by that is an approach that would allow us to get quantum computers into the hands of developers, customers, and users as quickly as possible so that we and they could learn from the use of those systems, and we could iterate as quickly as possible to the point where we could become commercial. As a result, we selected an approach to quantum computing called annealing quantum computing. We selected annealing for 3 reasons. First, it's much easier to scale annealing quantum computers than gate model quantum computers. Gate model is the approach that all the other quantum companies have selected. In fact, with respect to scaling, we are currently at over 5,000 qubits, while everybody else is at around 50 qubits. Second, annealing quantum computing is far less sensitive to errors. We're able to compute good solutions to hard problems today, even without the need for error correction. And finally, annealing is very well suited to solving optimization problems, and optimization represents most of the important hard problems that businesses need to solve. Moreover, that decision to pursue annealing quantum computing turned out to be even more important and more valuable to D-Wave than we originally thought. The reason is that we learned something very important about annealing and gate model quantum computing in the middle of last year. Specifically, at that time, it was shown mathematically, as well as demonstrated experimentally, that the gate model approach to quantum computing, the approach that everybody else is pursuing, is not good at delivering a speed up on optimization problems. In fact, the mechanism that's used today to enable gate model quantum computers to solve optimization problems has significant classical compute overhead, and this eats up all the benefit that the gate model system could otherwise provide on the optimization problem. But this is not an issue for our annealing quantum computers. Annealing quantum computers are native optimization engines and very good at solving optimization problems. This means that annealing is the quantum workhorse for solving optimization problems, and optimization represents more than 25% of the total addressable market for quantum. Since D-Wave is the only company in the world that delivers annealing quantum computers, this means that only D-Wave can address that optimization portion of the quantum market. Our second key differentiator is that D-Wave is a full stack provider. We provide everything from the quantum computers to the quantum cloud service, to the software development tools, to the hybrid solvers for combining classical with quantum resources, all the way up through to professional services. Moreover, we are about to take full stack to a new level. At D-Wave, we have invested over 10 years in researching, designing, and building our annealing quantum computers and solving the hard problems needed to make those systems commercial. We are now transitioning our annealing quantum computing program into a more traditional product development cycle where every couple of years we will bring out a new system with increased performance. What this means is that we now have significant research bandwidth to apply to a new class of hard problems. As a result, we announced several months ago that we're now also developing a gate model quantum computer. This means that D-Wave will be the only company in the world delivering both annealing and gate model quantum computers, and as a result, the only company in the world able to address the full set of use cases for our customers and able to access the full TAM, or total addressable market, for quantum computing. Our third point of differentiation is our Leap Quantum Cloud service. We brought our Leap Cloud service to market back in 2018 as the first and still the only real-time quantum cloud service. And we designed it not only to support research experimentation, but also to support business application in production by incorporating the reliability, the security, and the privacy needed to support such applications. Fourth, we have a proven track record of on-time product delivery for both hardware and software. Our current 5,000 qubit Advantage quantum computer is our 5th generation system, and we have demonstrated over and over again our ability to deliver both hardware and software on or ahead of schedule and on spec. And finally, we've demonstrated significant speedups on important real-world problems using our annealing quantum computer. And I'm not talking about synthetic benchmark problems, which are the types of problems for which speedups are being shown on gate model systems. I'm talking about important real-world problems. For example, the problem referenced on this chart is a magnetic materials phase transition computation that's known as the Kosterlitz-Thouless phase transition. The theory behind this won the Nobel Prize back in 2016, and we've been able to perform this computation on our system 3 million times faster than using path integral Monte Carlo and classical systems, which is the approach of choice for this type of problem. With respect to the total addressable market for quantum, we're using the Boston Consulting Group data, which is pretty much the data that everybody else in the industry is using. BCG estimates that the total addressable market is 2 to 5 billion in the near term, growing to roughly 450 to 850 billion in the 20+ year timeframe. Moreover, BCG estimates that about 20% of this is what's available to the quantum hardware, software, and services providers. This implies that the TAM for us and the other quantum companies is roughly $1 billion in the near term, growing to about 150 billion in the longer term. Moreover, BCG divides this TAM into 4 computational areas. Combinatorial optimization, that's problems like employee scheduling or manufacturing plant floor optimization. Linear algebra, that includes machine learning. Factorization, that's cryptography. And differential equations, that's what's required for quantum chemistry or computational fluid dynamics. As I mentioned previously, we now know that annealing is the quantum workhorse for optimization problems. And since only D-Wave provides annealing quantum computers, the optimization portion of the total addressable market is essentially accessible to only D-Wave. And while annealing can address linear algebra and factorization as well, the one area that it cannot address is differential equations. That requires a gate model quantum computer. However, once we bring our gate model quantum computer to market, we will be the only quantum computing company that is able to address the full TAM for quantum. Now let's talk about the readiness of the market for quantum. About a year ago, 451 Research, an arm of the S&P, did a survey of about 1,000 Fortune 5000 companies. What they found at that time was that over 4 in 5 of the companies surveyed had a use case in mind for quantum that they expected to start pursuing sometime within the next 3 years. Moreover, almost 40% of the companies surveyed said that they had a use case that they were working on today. More recently, Hyperion Research did a similar survey, and they found that it is now over 60% of the companies surveyed that have a quantum use case that they are pursuing today. There are 3 industries that D-Wave is currently pursuing. Manufacturing and logistics is the first, pharma is the second, and finance is the third. We are focused on these 3 industries because they are the industries that have very hard but very important optimization problems that need to be solved. So this represents the low-hanging fruit for annealing quantum computing and for D-Wave today. Moreover, every application that you see on this chart, for example, employee scheduling, protein folding, portfolio risk reduction, these are all applications that we are working on with our customers today. Similarly, every customer you see on this chart, for example, Volkswagen, Save-On Foods, GlaxoSmithKline, BBVA, these are all customers that we are working with. So let me now spend a minute drilling down on a few applications. I'd like to start with Save-On Foods. Save-On is a Canadian grocery chain. They came to us in the height of the pandemic when they found that a portion of their operations was becoming increasingly complex as a result of the additional requirements and constraints placed on them by the pandemic. In fact, for a particular optimization problem, it was taking them up to 25 hours per location per week to be able to solve that problem. At that time, D-Wave had a program in place where we were giving free quantum compute time to anybody working on a COVID-related problem. So under that program, we worked with Save-On Foods to map their application into our quantum computer, and they are now able to solve that problem in less than 2 minutes per location per week, down from 25 hours per location per week, a significant savings and a significant benefit. There are two important benefits to using quantum computing: a dramatic reduction in the time to compute the solution to the problem, a significantly better solution within the given amount of time for computing the solution to that problem. Quantum computing can aid in both of these areas, reducing compute time and delivering better solutions within a given amount of time. The third example that I want to spend a minute on is a portfolio optimization problem. This was work done by a partner of ours, Multiverse, for a European bank, BBVA. The problem was to compute the best return on a portfolio subject to a given risk profile as measured by the Sharpe ratio. There were several different portfolios and several different systems being used to compute the solutions. What they found was that on the largest portfolio, only two systems compute the solution. The first was Tensor Networks from Google, which is classical and took about 32 hours to compute the solution. And the second was the D-Wave quantum computer, which took less than 3 minutes, only 171 seconds to compute the solution. I mentioned that our go-to-market model includes both professional services and platform as a service. This chart shows our 4-phase engagement model, where the first 3 phases are professional services, and the 4th phase is that recurring revenue platform as a service component. In the first phase, we charge $50,000 for a 2-month engagement to help our customers understand which application or applications can most benefit from our quantum systems. In the second phase, we charge $350,000 for a 5-month engagement to build out a proof of concept for one of those applications. The third phase is also a $350,000 5-month engagement to help bring that application up in our customer's environment on a small scale, essentially to do a pilot deployment. And finally, the 4th phase is when we move into full production, where we charge between $500,000 and $1 million per year per application. The exact price is based on the size of the application, the complexity of the application, and the frequency with which the application needs to access the quantum computer. It's important to note that in this 4th phase, we are charging per application, not per customer. So if a customer has 2 or 3 applications, then they would be paying us on a recurring revenue basis separately for each of those applications. I'd also like to mention that every row that you see on this chart is a real customer and a real application. And many of these customers are Global 2000 companies. For example, our customers include companies like Volkswagen, as I've already discussed, GlaxoSmithKline, and Denso. And that essentially makes us quite unique in the quantum computing industry. We are focused on working with Global 2000 companies to help develop and deploy real business applications, as opposed to just focusing on government-funded research experimentation, which is pretty much where all of the other quantum computing companies are focused today. Okay, that's a little bit on applications, customers, and our go-to-market model. Let me now switch gears and talk for a few minutes about our products. As I said, our current generation quantum computer is our 5,000 qubit Advantage quantum computer. We brought that system to market about a year ago, and a few months ago, we made generally available our Advantage Performance Update. This was a new chip that used a modified fabrication process with some new materials to deliver even better performance than our original Advantage quantum computer. In fact, this system can deliver up to a 2x performance improvement on spin glass optimization problems, which are some of the hardest of the optimization problems. However, it's not just about the hardware. It's also about software. Our software includes our Leap Quantum Cloud service, our hybrid solvers for using classical compute in combination with quantum compute, and our software development tools. When we brought our Advantage Performance Update to market a few months ago, we also launched a new hybrid solver called our Constrained Model Solver. In addition to delivering better performance than our previous hybrid solvers, this solver for the first time raised the level of abstraction for developers building applications on our quantum computer. So specifically, if you're a data scientist or data analyst, and you're accustomed to building applications by using linear programming or quadratic programming or mixed integer programming, our new hybrid solver can now take those application models and automatically map them to the quantum computer. Moreover, when we bring our gate model quantum computer to market, we will be enhancing our cloud service, our software development tools, and our hybrid solvers to support both our annealing and our gate model quantum computers. Let me talk for a minute about our Leap Quantum Cloud service. As I mentioned, we brought this to market back in 2018 as the first real-time quantum cloud service. Leap is a very comprehensive service offering. It provides everything from real-time access to our quantum computers, to access to our hybrid solvers, to access to our complete suite of software development tools. It includes a full integrated developer environment so you can program your applications right there inside of Leap with nothing to download. It also includes application templates for quick start in developing applications and a whole host of learning and educational materials. Moreover, as I mentioned, this was designed not just for research experimentation, but also to support real business applications at production scale. Our Leap Cloud service is currently backed by our 5,000 qubit Advantage quantum computer and the Advantage Performance Update that we brought to market a few months ago. When we brought the Advantage Performance Update to market a few months ago, we also announced the roadmap for our next generation Advantage quantum computer called Advantage 2. This system will have over 7,000 qubits, increased connectivity, and increased coherence time. All three of these elements are extremely important because it's increased qubits, increased connectivity, and increased coherence time that allows us to solve larger and more complex problems faster and faster. In fact, our plan going forward is that every couple of years, we will deliver a new annealing quantum computer with more qubits, more connectivity, and more coherence. Finally, from a product perspective, I want to talk about our new gate model program. We also announced this a few months ago. What makes D-Wave unique in our approach to gate model systems is that we are focused on driving quickly to a scaled, error-corrected gate model system. We're not taking the same path that everybody else in the quantum industry has taken. Their approach has been to fabricate a few qubits, attach some I/O lines, and try to wiggle the qubits to get them to do something. That's experimentation. We're focused on commercial. We focused on commercial with our annealing quantum computer, and now we're focusing on commercial with our gate model program. This means driving to a scaled, error-corrected system as quickly as possible. And there are a number of very important and very challenging technologies that we had to develop as a part of our annealing program that are directly applicable to our gate model program. For example, multi-layer qubit fabrication. We are the only company that fabricates qubits in a multi-layer stack as opposed to a single layer on a wafer. This is very important because that's what allows us to get the qubit density that we are getting today. That's why we have 5,000 qubits when our competitors are generally at about 50 qubits. However, when you fabricate qubits with that kind of density, you become very sensitive to slight differences in the fabrication process across the chip. And as a result, the qubits can all perform slightly differently from one another. This drives the need to be able to tune those qubits. You need to be able to design and build qubits where you can read parameters from the qubits and then adjust those parameters to homogenize the qubits so that they all perform identically. This is very challenging and another hard technology that we had to perfect as a part of our annealing quantum system. Third is on-chip control. We are the only company in the world that has control on the same chip as our qubits. This is very challenging because of crosstalks between the control elements and the qubits. Actually, crosstalk just between qubits is very challenging. But once you add control, it makes it significantly more difficult. And we've worked through how to manage that so that we are now able to deliver systems that have control on the same chip as the qubits. This is extremely important as it's what allows us to read qubit parameters and adjust them. That's how we homogenize the qubits. It also gives us on-chip addressing and pipelining for rapid programming and readout. This is why we're able to control our 5,000 qubit quantum computer with only 200 I/O lines, where everybody else in the industry has 1 I/O line per qubit. Moreover, all of these technologies that we had to develop for our annealing quantum computer, they are all directly applicable to building a scaled, error-corrected gate model system. And we are the only company that has those technologies available. Our competitors haven't even started working on developing them. Before I hand it over to John Markovich, who is our CFO, to talk about financials, I want to take a minute to say that we also have a very strong and complete management team. The company is managed by myself and John. We have an exceptional R&D team in both hardware and software, and we have a complete go-to-market organization, including sales, marketing, and professional services. So thank you for your time. And now I'll turn it over to John to spend some time talking about the financials.
In preparation for this transaction, we have developed a very comprehensive bottoms-up 5-year financial plan and are projecting in excess of 160% growth in revenue over the next 5 years, commencing with a targeted $11 million in revenue for this year that represents a significant double-digit increase over last year's revenue. Approximately 40% of our 2022 $11 million revenue objective is supported by contracted bookings, with another 5% supported by the renewal of contracts that were entered into in prior periods. D-Wave has a highly diversified commercial customer base that includes approximately 24 Forbes Global 2000 companies. The growth in our revenue will be driven by a number of drivers, including the broadening of our customer base through significant expansion of our direct sales organization and our network of channel partners, with approximately 25% of the use of proceeds from this transaction to be applied towards our go-to-market initiatives. Also, an expansion in the number of applications that we are addressing with our customers, as well as an expansion in the number of applications that are being used by each customer. And lastly, an increase in the average transaction size or revenue per customer over the forecast period. Underpinning these internal growth initiatives is the projected growth of the optimization portion of the TAM that Alan highlighted earlier. Although we believe that we have virtually no competitors in the optimization sector, our financial projections assume that we only capture 15 to 30% of the optimization portion of the TAM, depending upon the year. And our revenue projections do not include any revenue contributions from the linear algebra and factorization portions of the TAM that our annealing technology can address, or from our gate model program. The 57 to 84% growth in gross margins is driven primarily by the gradual shift in our revenue mix towards the higher margin cloud-based platform as a service recurring revenue that increases from approximately 50% of total revenue to 95% of total revenue over the forecast period. The expansion in EBITDA margins closely correlates with the expansion in gross margins that reflects the high degree of operating leverage that is inherent in our business model, with EBITDA projected to turn positive on a sustained basis in the second quarter of 2025. With respect to the cash dynamics of the business, the targeted net proceeds from this transaction provides us with a fully funded business plan. Over the next several years, we plan to invest aggressively in software and systems development, as well as the go-to-market initiatives that I mentioned earlier. And we are projecting that the business turns cash flow positive on a sustained basis in the first quarter of 2025. We have a very capital efficient business model due to the relatively low cost of building our annealing systems, in combination with the magnitude of annealing compute capacity that we already have in place. Each one of our 3 production annealing systems can support approximately $25 to $30 million in annual revenue. Now let's talk about the transaction structure. Although we believe that our targeted valuation compares very favorably to other quantum computing companies, particularly given our degree of commercial traction, we have decided to provide our shareholders with an incrementally more compelling reason to invest during this challenging market environment. To facilitate this, we have established a pool of an additional 5 million bonus shares to be allocated to the non-redeeming SPAC shareholders upon the closing of the transaction. This pool of 5 million bonus shares will be allocated to shareholders that do not redeem their shares in the SPAC, and these shares will be allocated on a pro rata basis across all non-redeeming shareholders. This structure is designed to incentivize the public SPAC investors to retain and not redeem their shares in the DPCM Capital SPAC. As set forth on page 24 of the investor presentation, as redemptions increase, the cost basis to the non-redeeming SPAC shareholders decreases. As an example, if there are no redemptions of the public SPAC shares, all SPAC shareholders will receive a total of 5 million bonus shares that will result in the lowering of their cost basis to $8.57 per share, or a 14% discount to the $10. Under a 50% redemption scenario, the non-redeeming SPAC shareholders will receive a total of 5 million bonus shares that will result in the lowering of their cost basis to $7.50 per share, or a 25% discount to the $10. We believe that this very innovative structure will be quite compelling to the public SPAC investors, given the inherent downside protection that it is designed to address. We have implemented a very similar structure for our PIPE investors with an additional pool of up to 1.8 million bonus shares. The bonus shares will be allocated to PIPE investors to ensure the same cost basis as the non-redeeming public SPAC shareholders. This concludes our presentation, and on behalf of D-Wave Systems and DPCM Capital, I would like to thank you for your time and interest in our very exciting company.